Now in this part, we are to look into the application of the linear functions to business contexts. So the first one that we are looking into is demand curve. So the most simplified version of demand is line. It's linear, right? So here is one example. Q equals to 100 minus 2P. And here Q is the quantity demanded and P is the price. So the slope minus 2 tells us how quantity will change from a unitary change in price. So say that means price raised by $1, quantity will drop by 2 units. So why do we say it's demand? It actually makes sense, right? Because we consumers, we are sensitive in price in a negative relationship. How do we say this? It's basically we see the price being higher, then we want to reduce the consumption. That's basically what it is. So, and it makes perfect sense in that price seems to be the driving force of your consumption, right? So price is like the cost, and Q, quantity consumed, namely the scale of your consumption, is like the consequence. So we would like to put the cost, the leading force, the driving force, to be the independent variable, and the consequence, which is a passive result of the change in price, right? We put quantity, therefore, as the dependent variable, right? The quantity is a certain value dependent on the price, dependent on a certain price level. So that's why normally we put Q on the left-hand side in the position of Y, and P on the right-hand side of the equation in the position of X. But sometimes, for facility of calculation and graphing, okay, we do it the other way, which is to graph P as the y-axis and Q as the x-axis. In that way, the function will be like this. P equals M minus BQ, where M and B's are numbers, namely parameters. Okay, so this one is what we call an inverse demand. And in the next slide, in the following practice question, we are to experience the application and see the reason why we do this. Okay, so let's now switch to the document camera to look at this problem. So this problem is that quantity equals to 100 minus 2P, okay? And our first task is to find the inverse, in which you need to swap the position of P and Q. So now Q is in the position of Y, P is in the position of X. So now let's swap it. So our target then is to convert this function into something like P equals to M minus BQ, and we need to find M and B. We need to find those numbers. So let's just do it. So here, for clarity in demonstration, I'm just doing this step by step. So first, we need to have P on the left-hand side. We keep everything else the same, but P on the left-hand side means we need to move minus 2P to the other side. And as you are moving side, don't forget to change the sign. Okay, so now 2P plus Q equals to 100. But we need to P itself to stand alone. Q should not be on the left-hand side. We need to move Q to the other side. So we have 2P equals to 100 minus Q. Is that all? No. The coefficient of P should be 1 so that we can omit it. It should be like Y equals to 2X plus 100 or 100 plus 2X, right? The number before Y should always be considered as a default so that we can omit, which is 1. So here, how do we make the coefficient to be 1? We need to divide 2 to the two sides, to both sides of the equation. So it's P equals to 100 over 2 minus Q over 2. That is 50 minus half of Q. So that is the inverse. And that is actually question 1 on your slide, page 22. So now question 2, calculate the price if firm sells 20. So now you see, if you know Q equals to 20, then what you, and if you have already figured out the inverse, then what you need to do is just to plug this in. So in that case, P, the market price as 20 units was sold to the market, is supposed to be 50 minus 1/2 by 20, with Q being 20 plugged into this equation. So we have 50 minus 10 equals to 40. So that's your question 2. And your question 3, calculate inventory when the price is 30 and the firm produces 75. So the market price is 30. So the first question is you need to figure out the corresponding demand, right? The demand is just to plug 30 into the original. So now you're given a price. You're asked to calculate the corresponding quantity. So it's easier for you to use the normal form. I'm not saying you can't use this. If you use this, you need to solve, right? It's that P equals to 30 and you plug this into the left-hand side, then you need to solve for Q. You can still do this, but it's just less simpler than this. Now, if you're using the normal form, then the corresponding quantity consumed is 100 minus just 2 times of 30, where P equals to 30. You just plug this number in. So that is 100 minus 60, which is 40. Okay, so this is what consumer consumes, right? But the firm actually produces what? 75. Okay, and the difference, which is what the firm produces, 75, but the consumer in the market only needs 40, right? Then you produced 75, you can only sell out 40. The remaining 35 ends up your inventory. So that's the application, first application of the linear case.